So we're just graphing this to see what our calculator zeros are. So we can see there's 1. Let's see where it's at. It's there at 4. So we've got our calculator 0 is at 4, which means we're going to have 3 other solutions we're looking for. So first thing we want to do is synthetic division. Divide out that one factor we already know. So bring down the 4, multiply, add, multiply, add, multiply, add, multiply, and add. So here we go. We've got x cubed minus 4x squared plus 4x minus 16. Now, since we've got 4 terms here, we can go ahead and do factor by grouping. So if we group these terms together, we can factor out an x squared here. We're left with x minus 4. We can factor out a negative 4, so that we're left with x minus 4 again. So this factors to become x squared minus 4 and x minus 4. Sorry, x squared plus 4. X squared plus 4. There we go. Now, notice our calculator 0 we already have was at 4. Hey, look, this x minus 4 equals 0 is getting us another solution of 4. So that means our 0 at 4 has a multiplicity of 2. So we need to find just the other 2 solutions then. So we'll take the x squared plus 4, set it equal to 0. We'll get x squared is equal to negative 4. Take the square root. X will be equal to plus or minus 2i. So our zeros, we have 4, which has a multiplicity of 2 because it's occurring twice, and then a positive 2i and a negative 2i. All right, we should have 3 zeros because that's our highest power. So let's plug it in. You've got x to the third minus 4x squared minus 15x plus 68. So we're looking for calculator zeros. We see 1. So let's figure out where that 0 is at. It's on the left side, so it's going to be in the negatives. There it is at negative 4. So our calculator 0 is at negative 4. We will divide that factor out. So we multiply, then we add, and then we multiply, and then we add, and we multiply, and we add. So here we've got 1x squared minus 8x plus 17. Now again, we saw these aren't showing up on our graphs. That means we're going to have imaginary solutions. We'll go ahead and use quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac. I went ahead and did it for you. It's negative 4, all divided by 2a. So that square root of negative 4 simplifies to 2i. And this will simplify to 4 plus or minus I. So our 3 solutions are negative 4, 4 plus I, and 4 minus I. Let's do another one. We're going to have 3 zeros. Let's plug it in. We've got x cubed minus 6x squared plus 7x equals 0. So again, I can see a factor of x I could factor out, so I know I'm going to have a 0 at 0. And there it is. Now the other ones don't look like they're at nice spots. We could try and do the intersection. If you tried though, you'd get some really kind of funky decimals. So we're gonna just use this factor of 0. We're gonna refactor this then, get x squared minus 6x plus 7. We know these are gonna be weird numbers here. So let's go ahead and plug it into the quadratic formula just to see what we get. x equals negative b plus or minus square root of b squared minus 4ac, that's 8, all over 2a, which is 2. So this simplifies. 8 breaks up into 4 and 2. That means we can pull a 2 outside. We're left with a root 2 inside over 2. This will simplify to 3 plus or minus root 2. So our solutions will be 3 plus root 2, 3 minus root 2, and then the 0 we found with our calculator. And let's try one more of these. So we know there's going to be 5 zeros this time. Just looking at the equation, I already know one of them is going to be happening at 0 because you can factor one out. We've got x to the 5th minus 8x cubed minus 9. So let's check our, oops, must have plugged something in wrong. Messed it up again. X to the 5th minus 8x cubed minus 9x. That's what I missed. This thing will let me get over there. Go. Minus 9x. There we go. Maybe. Now we can graph it. All right, there's the 0 at 0 like we were expecting. You can see there's 2 other zeros. Here's one at negative 3. And there's one at positive 3. So we've got 0, negative 3, and positive 3 showing up already. So if I factor out that original x, we can go ahead and use synthetic division twice here. Yeah, x to the 4th, 0x cubed, negative 8x squared, 0 x's, and a minus 9. Bring it on down, multiply, add, multiply, add, multiply, add, multiply, add. And then we'll do it again to factor out our other factor that we know. So we'll take our result from up here, bring it right on down so we can divide again. So we multiply, then we add, we multiply, we add, we multiply, and we add. So now we're left, this function started at x to the 4th, this one started as x cubed, so our solution down here is going to be x squared plus 0x plus 1. So set that equal to 0. X squared is equal to negative 1, which means that x is plus or minus I. So our 5 solutions, 0, negative 3, positive I, and negative I. So we can actually write a function just if we know the zeros. The big thing here to recognize is that if we have an irrational root, so something with a square root inside, adding or subtracting something with a square root, or something with an imaginary number. Anytime we have those, you notice they always came in pairs. If we have, like we did up here, if we have a positive I, we're also going to have a negative I. So when you write a function in simplified form from its factored form, if they tell you one root that's got something with a square root in it, like an a plus b root c, or if you have an imaginary root, it's always got to come in pairs. So if they tell you one of the solutions is positive 3i, another one has to be negative 3i because they always come in pairs. So, for example, if we want to write the function that's got solutions of 2, 3, and 1 minus I, because complex zeros come in conjugate pairs, they always come in a pair, 1 plus I must also be a 0 of the function. So we're going to use this here in the next video to write the standard form of this function.